Welcome to July 11th LeetCode Challenge, Binary Tree, Right Side View. Given the root binary tree, imagine yourself standing on the right side of it. Return the values of the node that you can see in order from top to bottom. So for example, number 1 here, we're given this binary tree, and one of the view from the right side, going from top down, should be 1, 3, and 4, as such. Given this binary tree here, we have basically 1, null, 3. If we look at it from the right side, we see basically from top down be 1 and 3. And if we have an empty root tree, then we obviously see nothing, so we're therefore return nothing. The number of the nodes of the tree ranges between 1 to 100, and the value of each node is between -100 to 100. Alright, let's kind of solve this. So obviously it's a tree type question. Two ways to solve it, using depth first search or breadth first search. I am going to choose a breadth first search. Let's call this, so the first thing we do is have an output, and that's going to be our empty array. So the first thing we want to do is if not root, if root is empty, return output right away. So return something empty. And then we pretty much develop what's called a double-ended queue. So we call it deque, double-ended queue, going to be deque, and that's going to contain our root. So far, so good. We are going to perform a breadth first search, traversing through the tree. Let's see. Let's do it this way. Let's not put the root inside. Let's just call it outside. So if root exists, then we are going to append the root. Alright. While the double-ended queue exists, we are going to do a for loop that's going to iterate through each index I in the range of our length of our queue. Let's see, that's -1 in reverse order by decrements of 1. So we're reversing through the queue in decreasing order. We're going to develop something called a node. And that's going to be our double-ended queue dot pop left. Alright, we assign that. So if we have I is equal to 0, so now we're checking all three sides, then our output is going to be appended by our node dot value. If node dot left exists, then we're going to append the node dot left value. If node dot right, we're going to append the node dot right value. So this is traversing through the breadth first search, and then we should be able to return our output. Okay, let's see if this works in some way. Ta-da! I think it got accepted. So basically, let me refresh this. Right, that got accepted. So basically what that is using a double-ended queue, it's using a breadth first search approach, traversing through each range, each layer level of the tree in order to find whether it is the value that you want to append or not to the output. Alright, we just keep on appending everything to the output as we could see it if I is equal to 0. That's pretty much it. Time complexity is big O of n. Memory complexity is big O of h, where h is the height of the tree, because at most we are going down the height of the tree. Alright, that's it. That's all. Have a great day, guys.